Chi-square test. When we have one categorical variable and two or more populations, then we can use chi-square homogeneity test. We want to infer whether two or more population distribution are homogeneous for all the levels of the outcome variable. Example: someone wants to know whether male and female have different weight status, underweight, normal, overweight, obesity, in XYZ region. To deal with this problem, we can select samples from male and female population separately, using simple random sampling method, in that region. Hypothesis for test of homogeneity. Null hypothesis: all population are homogeneous according to all levels of the outcome variable. Alternative hypothesis: all population are not homogeneous. For the example, hypothesis will be: null hypothesis, proportion of males equals proportion of females for each level. Alternative hypothesis: not all proportions are equal. See test statistic formula under the null hypothesis, where OIJ equals observed frequency for the ith level in JTH population. EIJ equals expected frequency for the ith level in JTH population. The test statistic follow chi-square distribution with degrees of freedom, number of population -1, into number of categories -1. Decision rule. Critical value method. If calculated test statistic greater than critical value, we reject null hypothesis, else we failed to reject the null. P-value method. If p-value less than alpha, we reject null hypothesis, else we failed to reject the null hypothesis. Let's solve the problem in the example. Suppose we have surveyed 100 male and 70 female in that region. Then their weight status data were collected, are given in the table. Here these frequencies are observed frequencies. Remember we surveyed a fixed number of males and females. That's why gender is not a variable here. It's time to calculate expected frequencies. Expected frequency for the IJTH cell can be calculated by the formula equals ITH column total into JTH row total, divided by grand total. Calculate all expected cell values in similar ways. Now, we can easily calculate test statistic value from observed and expected frequencies. Here, test statistic follow chi-square distribution with degrees of freedom equals 2 - 1 into 4 - 1 equals 3. We can get critical value at certain alpha from chi-square table or also can calculate p-value using statistical calculator. Now, easily we can make the final decision.